Today we're going to do a two-tailed one proportion hypothesis test from Chapter 9. So to access it, we have to go to my teaching website, Chapter 9, Case 9. Now, I've already frozen the data over here. So if you recall from previous cases that I've demonstrated on YouTube, when I hit F9, the responses change. I've already copied and pasted in the values, so that's already taken care of. And if you notice, there are 195 observations in this variable. So our sample size is 195. We're going to use the data to answer the question on the spreadsheet. Market research that was conducted by Marketing Partners, LLC, found that 64% of soft drink consumers are aware of your chief competitor's soda, Dr. Thunder. You have hired the same firm to determine product awareness of your soda, Dr. Rocks. The data in column A were collected by this firm. Use this data to determine if your soda, which that red phrase is the proportion of consumers who are aware of your soda, has the same as in bold because it means equal, product awareness as Dr. Thunder. Dr. Thunder's product awareness is the hypothesized value. So that last sentence in the problem represents the null hypothesis. What does it say? The proportion of consumers who are aware of your soda, the red P, equals the proportion of consumers who are aware of Dr. Thunder, 0.64. The alternative hypothesis says what? The proportion of consumers who are aware of your soda is not the same as the proportion of consumers who are aware of Dr. Thunder. Let me go back up here and make the 64 blue and bold, because that 64 there is what we're talking about here. With a hypothesized value in cell G10, I'm going to restate the null hypothesis and the alternative hypothesis in equivalent forms. So the null hypothesis here is we have this difference between the population proportion and the hypothesized value of 0.64, and that equals 0. In the alternative hypothesis, the difference between the population proportion and the hypothesized value 0.64 is not equal to 0. So how do we test this? Well, the test statistic is P bar, the point estimate of P, minus P0, the hypothesized value. That difference, point estimate of that difference, is the numerator of the z-stat. The denominator is the standard error. So the first thing we have to do to compute the z-stat is find the P bar. And the P bar is just the count of yeses in this big blue box here that goes all the way down to cell 196. So we want to count all the yeses. And how do we count all the yeses? Well, we type equal count if, and then we type A2 to A196 because that's where the yes and no's are, and then comma, quote unquote, yes, unquote. We divide that count by the sample size, which happens to be 185, which is located in cell E16. Next, we want to calculate the sigma squared for the z-stat. And if you recall from earlier discussions, the z-stat in one proportion hypothesis testing is the hypothesized value 0.64 times 1 minus the hypothesized value 0.64. The numerator of the z-stat is, again, the point estimate of this difference. P bar is the point estimate of P, and then P0 is the hypothesized value of 0.64. So to get the point estimate of the difference, we take P bar minus the hypothesized value. The denominator is a standard error, and the standard error is computed by taking the square root of the sigma squared, dividing that by n. And that's what we did here. We got square root, parentheses, the sigma squared, divided by n, which in this case is 195. And that's your standard error. The test statistic is the ratio of the point estimate of the difference and the standard error. The point estimate of the difference is negative. The z-stat is negative. And so these statistics are pointing to the fact that the difference is negative. So the less than part of the alternative hypothesis is true. So we have a difference. That difference is negative. Now we need to know if that difference is significant and negative. And we do that by comparing the z-stat to the critical value. So significance is the alpha level, and the alpha level is equal to 0.05. Now remember, the alternative hypothesis is a two-tailed test, so we have to divide the alpha by 2. So when you divide alpha by 2, you get 0.025. Now we can get the z critical values from the standard normal table, or as I like to call it, the z table, or we can get the critical values of the test from the infinity row of the t table. If we go to the t table, we are going to start by going to column 0.025, and then we're going to go to row infinity of the t table. So now we're going to go to my website, halsnarr.com, and the teaching page, and we're going to scroll down until we see the z, t, chi-square, and f distribution tables. The first thing we want to do is find the 0.0250. We're going to find that in the standard normal table. So where is 0.0250? Well, 0.0250 is in row -1.9 and column 06. So our critical value is 1.96. Let's go to the t table. And notice in the t table in column 0.025, the z values are around 2, or the t values are around 2, but as the degrees of freedom and the sample size increase, the t values get closer and closer and closer to 1.96. In fact, in the infinity row, the t value becomes z, 1.96. So whether we use the t table, the infinity row of the t table, or we use the standard normal table, we get 1.96 as the critical value. Now the question is whether the z-stat is inside these two numbers. If the z-stat is inside these two numbers, then our difference here, this difference, is said to be insignificant. Or there is no difference here. This difference is insignificant, which suggests this difference is 0. So if the z-stat is in between these two values, this difference is insignificant, and we conclude that perhaps this difference is 0. So we have evidence in support of the null hypothesis. However, the z-stat is not in between these two. So this difference is not insignificant, which suggests that this difference is less than 0. So we're going to reject the null hypothesis. When we reject the null hypothesis at 5% level of significance, what is that saying? We're rejecting the null and we're accepting the alternative. Now, what is the alternative hypothesis in English? If you go back to the original problem, this statement here is the null hypothesis. Your soda has the same product awareness as Dr. Thunder. So what is the opposite of that? The opposite of that statement, Dr. Rocks does not have the same product awareness as Dr. Thunder. In fact, because our z-stat is negative, you could actually say Dr. Rocks has less product awareness than Dr. Thunder, which means the company might have to rethink its entire marketing campaign. Maybe run more ads, maybe run more internet ads, maybe run better TV ads. Now that concludes hypothesis testing for one proportion, in particular case 9 of chapter 9.